Going to start the third chapter today, 3.1. Maybe this looks a little familiar to you. We're going to look at y equals mx plus b. So the question for today, how do you write an equation in slope-intercept form? And then we're going to use this information to graph the linear function. And hopefully you've heard both of those words before. So some definitions of these words for constant increase and constant decrease. So whenever you have a line graph, that just means the line increases at the same rate. If it's constant, it's going to go up the same amount all the time. We talked about this before when we talked about slope. Slope means it has a constant rate of change. So same thing here. This is going up or this one's going to be going down. So on a line graph, the line decreases at the same rate. So they call it a constant increase or a constant decrease. All right, let's try an example. So for these ones, we're going to do some word problems that we're going to have to come up with our own equations in that form, the y equals mx plus b. So I'm sure you've created equations like this before. So let's see how to do it. Example 1, Josh usually waits until he has only 1 gallon of gas left in his car before filling up. Suppose the gas pump pumps at a rate of 4 gallons per minute. So hopefully you can try to identify, we're going to try to identify these numbers, m, the slope, and b. So let's see if we can figure that out. Part A, write an equation for a function representing the amount of gas in Josh's tank X minutes after he starts pumping gas. So he's going to the gas station. He only has 1 gallon to start with. And we're talking about how much time it takes for him to start pumping the gas. And it pumps at a rate of 4 gallons per minute. So these are the only two numbers they give us. He starts with 1 gallon, our starting point, and how much is it pumping? 4 gallons per minute. Usually when you see this word per, that means that's going to be your rate or your slope, all those things. So let's identify the equation. We're going to do y equals mx plus b. So which one would go where? What goes in for m, what goes in for b? Well, if we're starting with 1 gallon, that's your starting point. That goes in for b. And your rate, 4 gallons per minute, will go in for m. So it's going to look like this. Y equals 4, because gallons per minute, x plus 1. And then we're also going to label what y and x stand for. So y and x. It said that x stood for minutes here, so we'll do that. Minutes. And what's the y value stand for? Well, he's pumping 4 gallons per minute. And if we keep pumping it for so much time, this is going to give us the total amount of gas, right? And then the last thing we're going to do is graph it. So I think we can probably just go by ones on both the x and the y axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That should be enough. And then going the same way up. 5, 10, 15. So how do we graph this? If you remember, you start here. That's your starting point at 1. So I'll put a dot at 1. It goes on the y-axis. And then we're going to count. This is our slope. So we're going to go up 4 over 1. We did this a long time ago, probably like the first week of school. Did a worksheet on this. So we're going to go up 4 blocks. 1, 2, 3, 4 over 1. Keep going. 1, 2, 3, 4 over 1. 1, 2, 3, 4. Here we go. 1, 2, 3, 4. And that's all we can do. And then, as best you can, we're going to connect the dots. I won't be able to do it that well, but I'll try. Something like that. It goes up. So that's our equation and our graph for 4x plus 1. All right, some vocab. So where we started at was called the y-intercept because that's where it crosses the y-axis. So the point on the graph that crosses the y-axis. That's called the y-intercept, which is your number out here, the 1. And this is also called a linear function. So if you see the word in here, has the word line. They make straight lines called linear. So that's a function whose graph is just a line. So we just drew a diagonal line. And the last piece here, slope-intercept form, that's actually what we were just looking at. Y equals mx plus b. It's called slope-intercept form because, let's just highlight this. The slope is m. The intercept, specifically the y-intercept, right? The y-intercept is b. So it says it right here. M is the slope, and b is the y-intercept. Thus, slope-intercept form. And you've probably heard that before. All right, let's try another one. Example 2. A pond with about 26 acre-feet of water needs to be drained for repairs to its levee. Engineers determined that 8 acre-feet of water can be safely drained per day. So it's pretty important to highlight the two numbers. We usually only get two numbers, and then we get to plug it into the slope-intercept form. So we're going to write a linear equation to model the situation. So let's start with our generic one, y equals mx plus b. So you have to figure out what is the slope, and then what's the starting point. So maybe you can figure out which one number goes where. So which one's which? So we're starting with this amount of water, 26 acre-feet. And what we're doing is we're draining it. So it's going down. How much is it going down by? 8 acre-feet of water per day. It comes a little later, but over here it says per day, and we're going down by 8 acre-feet of water. So let's just fill in the blanks. So we're starting with 26. So we put plus 26. That's your starting point. And since it's going down, what do you think we're going to put in here? Not just 8. Since we're draining the water, we want to go ahead and throw a negative in front of it. So it should be negative 8x plus 26. Okay, before we do that, I think we're going to go ahead and graph it. Maybe not. I guess that's not part D. I think we'll wait till we graph it right now. I should also maybe label some of this stuff. So y and x. So what does each one stand for? So what would we say y and x stand for here? I think we're going to say x is going to be the number of days. Try this again. So what does it say days? I can at least label it on the axes before we graph this. Days. And the y would be, well, if we wait a certain number of days and we're draining this, that would probably be the amount of water that's left, right? So how about total water? Let's see. I forgot to label this axis. This is supposed to be minutes. And this is supposed to be total gas. If you got confused with how to graph it. Anyway, so this is days, and this is going to be amount of water, so total water. Okay, we're not going to graph it just yet, though. And how many days will the pond be empty? Well, we know it's draining, 8 acre-feet per day. So how would we figure that out? Well, if we know that y stands for how much water is in it, we would know how much to put in for y if we want it to be empty. If we want it to be empty, we're going to just use the number 0. So 0 equals negative 8x plus 26. Now we're just going to solve for x, because x stands for number of days. So let's plug that in, plug 0 in, solve for x. How do we do that? 2 steps. Minus 26 on both sides. That's gone. So we get 0 minus 26, which is negative 26, equals negative 8x. And then divide by negative 8. They'll cancel out. So how many days will it take? You divide those and see what you get. It should be a positive number. And it's a decimal, but it's not a very long decimal. Got about 3.25 days. So that's how long it will take for it to be empty. So sometime after the third day. C. What are the y-intercept and the slope of the line represented in by your equation in part A? So if we look at part A, what is the slope and what is the y-intercept? Remember, this is the slope right before the x. That's always the case. And there's your y-intercept. So let's just label it. Y-intercept will be 26. That's our starting point. Slope is -8. Now, last part, we can finally graph the line, and then we're going to indicate where the reservoir is going to be empty. So hopefully we can see that it's close to the 3.25 days. So I'm going to go by, I don't have to go too many days, so maybe I can space this out. Every other block is 1, 1, 2, 3, 4, 5, 6. So we can get out to 7. And then for my total water, since I'm starting at 26, I need to at least make it up to there. I think I'm going to go by 2s. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Takes me up to 20. 2, 4, 6. There's 26. 20, 2, 4, 6. So there's 26 right here. That's a good starting point. All right, let's change colors and actually graph this now. So we're going to start at 26 on the y-axis because that's your y-intercept. Now you have to be careful when we count blocks because every single block here is worth 2 on the y-axis, but you have to go over 2 blocks just to go over 1. So you got to remember that whenever we count blocks. Our slope is -8 over 1. So if you want to do that up here, you can put that up here. So we're going to go down 8 over 1. But going down 8 actually means you're going to go down how many blocks? 1, 2, 3, 4. That gives you down -8. And to go over 1, you actually need to go over 2 blocks. So 1, 2, 3, 4, and then over here. Looks like that. -8. So 2, 4, 6, 8, and then over. Then go down again. 1, 2, 3, 4. That'd be 2, 4, 6, 8. Over another one. And I don't think we have enough space to do another dot. So if we connect these dots as best we can. Oh man. That's so good there. Can I try it again? I tried. So draw a straight line as best you can. If I had a ruler, it'd be a little bit better. And we're also supposed to indicate where the reservoir is empty. So if you look at this line up here, where do you think it would be empty? Well, since this is considered the total water and it's just going down and down and down, we want this level of water to go down to 0. So we're looking at where it crosses right here. And so that would be right around here. So I'm going to indicate that. That should be, if you can see it, it's kind of like halfway between 3 and 3.5. That's what this line would be here. And that's where you get your 3.25. So it should match the equation when we did the actual math and got 3.25. It should match up with the graph. So that's where it's empty. So what we just found there, looking here, this would be where it crosses the x-axis. So they call that the x-intercept. No surprise there. A point on a graph that intersects the x-axis. I think we only have this last one to do. Yep. Our last one, we'll practice graphing some more. Graph y equals 2x plus 3, and then y equals 2x minus 4. All right, so this would mean if we do this one, I'm going to change colors for these as well. So at 3, we're going to go up to 3 and put a dot. And then this means to go up 2 over 1. So up 1, 2 over 1. Put a dot. Up 2 over 1. Up 2 over 1. And you can go the same direction the other way. Down 2 over 1. Down 2 over 1. Down 2 over 1. Okay, and then draw your line. Really not good at drawing straight lines on this. There we go. So that's the red one. Let's change to blue. So for the second one, we're going to start at -4 on the y-axis. Put a dot there. And the slope is up 2 over 1. Up 2 over 1. Keep doing that. Up 2 over 1. There we go. And then down 2 over 1. And connect the dots. There we go. That was the blue one. Part A, will the lines ever intersect each other? Hopefully you can see, even though I don't have very straight lines, that you should be able to tell that they do not. No. So why does that happen? You might know that when you see these two lines and they don't intersect, you might think, hey, well, that means that they're parallel. Well, I know they're parallel. Obviously, that means they don't intersect. But why don't they intersect? If you go back to the equations, what makes them, if you just look at these two equations, how do you know that they're not going to intersect? Before you even graph it. What do they have that are the same? Right there. They both have the same slope. So they have the same slope. So anytime that actually happens, if two equations have the exact same slope, but a different y-intercept, because they start at different places, they will never intersect each other, because they're going to go up and over or down and over to the same amount every single time, because they have that constant rate of change. I think that's the last thing we have to go over. So in the box below that, parallel line and slope theorem. So this says two non-vertical lines, that just means they're not straight up and down. Otherwise, that wouldn't be a function. They're going to be considered parallel only if and only if they have the same slope. So it goes both ways. If you have the same slope, parallel. If you see that they're parallel, they must have the same slope. I think the rest you should be able to finish. I might go over like 1 or 2 and then be done. Let me quickly go over something like this, like number 4 on the huddle. Tell whether each situation represents a slope of 3 over 2. So this is going to tell you to move left, right, up, and down. You just have to figure out and see if it's going to work. So a vertical change of 3 units for each horizontal change of 2 units. Remember, it's rise over run. So your first one should be a vertical change. So it's saying to go up 3 and then change horizontal change over 2. So as a slope, that would be 3 over 2. See, they match perfectly. So is it the same slope? Yes. I don't know if you're supposed to write yes. Seems like you should. It says tell where each one represents the slope of 3 over 2. So that does exactly. Part B, a vertical change of 1.5 units. So we're going up 1.5 and a horizontal change of 1. So is 1.5 over 1 the same thing as 3 over 2? Well, if you actually divide 3 divided by 2, you get 1.5. And you can put that over 1. So that's also a yes. And the last one, vertical change of -6. That means we're going to go down 6. For each horizontal change of -4. So that means this way, -4. So you do -6 over -4. Maybe you can see it better if I erase. I'll put it right on the line here. -6 over -4. So that reduces. The negatives will cancel each other out. And then you can reduce them both by 2. Divide them both by 2. So 6 divided by 2 is 3. And 4 divided by 2 is 2. Same slope as the original. So these are all yeses. I think you'll have homework questions like that. And the last one I want maybe cover is 2 on the mastery, about the temperature of an oven. This first part can be kind of confusing. It says to convert the rate of change to degrees Fahrenheit per minute. So it's asking you to take divide the temperature by the time. So this last part here, it says it takes 20 minutes to drop 190 degrees Fahrenheit. So you're going to take the degrees Fahrenheit and divide it by minutes. So 190 and divide that by 20 minutes. They're basically asking you to find what your slope's going to be. Once you divide them, then you're going to use that down here when you do the y equals mx plus b, and your m value will be whatever you get here as your slope. It's going to be your degrees Fahrenheit per minute. I think the rest of it should be fine for you to finish. So that's all for 3.1.